So the point of this recording is to use Gemini 1.5 Pro and its giant context window. It's the first time I've ever used it to try to port a medium-sized piece of software from Kotlin into other languages. First, I'm going to try Kotlin into C#, and depending on how that goes, maybe Kotlin to Python, Kotlin to Go, see how that works. So the thing we're going to be porting is Selfie, which is the snapshot testing library. It's written in Kotlin multi-platform, so it works for JVM, almost works for JS. There's a team that's porting it to Python by hand right now, or by hand with ChatGPT's assistance. But we're going to see how Gemini 1.5's context window does it just one shot. So it's a snapshot testing library that does snapshots on disk or snapshots in line. That's the usual stuff. One fancy feature it has is it's lensable. So this means if you had a whole bunch of HTML that you were snapshotting, you can add other lenses of looking at it. So for example, rendering that HTML into Markdown, and then you can mix disk snapshots with inline. So you put the full raw HTML on disk, and then assert on the Markdown rendering of that HTML inline to make the snapshots readable. And then it also has this caching functionality, so you can have, instead of doing an expect selfie on a value where you're doing your snapshot testing against a value, you can do your snapshot testing against a function, and the function only runs when the snapshot isn't written. There's some, it's a little tricky, but that could be really handy with like LLMs or any kind of expensive AI endpoint. The code we have, it's here on GitHub. There's selfie lib, which is like all of the functionality that makes the snapshot testing work. And then we have runners for different test runners. So JUnit 5 for the latest JUnit, and then CoTest, which is the Kotlin multi-platform runner that runs against CoTest. So we're gonna start off by just porting selfie lib. And the other part of the stream, like I have never written anything in C#, but from looking at the language features, I can see it's very similar to Kotlin. What are the most popular C# test runners? Well, ChatGPT figures this out. So in Java world or Kotlin world, there's selfie lib, and then selfie runner JUnit 5, selfie runner CoTest. So in .NET world, there would be selfie lib, and then selfie runner -NUnit, selfie runner XUnit, selfie runner MS test, it looks like. But we'll start off with just the lib, because it has the most unit tests, straightforward thing to port. So here's Gemini 1.5 Pro. I just got access. So prompt will be import to C#. So amazing. Looks like I can just go to selfie, JVM, selfie lib. Unupload selfie lib, but without the build. So I will go to selfie lib. I'll go to JVM, selfie lib, delete this build. Okay, so now when we upload selfie-live, we'll load the build, we'll load its markdown, and we call it source code here. So we'll add all those text files, and I'm just going to say port all of this Kotlin into idiomatic C#. That's all. Like I said, I've never used Gemini. And it didn't work at all. Interesting. So here's token count. So this I see. So when I add the folder, it sits here in chunks. Okay, so I should wait for this to finish. Well, this is that classic progress bar thing. Let's see. There we go. Amazing. So the whole only 55,000 tokens in this whole project. And now all of this Kotlin into idiomatic C#. I've heard that Claude 3 is a remarkable code model too, with the big context window. So maybe, I don't know what the exchange rate is between Gemini tokens and Claude tokens, but 55,000, so that should fit. Here's a breakdown of the provided Kotlin code with notes on porting to C#. Module selfie lib. Line reader. This class provides functionality for reading lines from a string or byte array. Some functionality in the stream reader and string reader. That makes sense. Call location, atomic. Tell it provide C# code. C# code for every Kotlin class. This one that it provided, seems right. It's impractical. It says it's impractical. But it's doing a job. So what if I said provide a full implementation of per character escaper. This is a good one because per character escaper is a pretty long, one of the longer classes in the whole thing. While this is loading, let's look at what we're asking it to do. So per character escaper is, there you go, 150 lines. And it has this escape policy. So it lets you pick which characters are getting escaped and how. That looks right. So I guess if you tell it to just do it, it says it's too hard. But if you list one specifically, it seems like it does it fine. If I said list every Kotlin class. This is where it being lazy, the places where it's lazy, would match fine with old school, like parse the files. So it's told to do per character escaper. There's some duplicates. It's not perfect. See, the one that worked good was find a full implementation of, let's see what array backed. Yeah. Full implementation of array backed LRU cache. And of course, like, we're not, for actually compiling these, it would be a lot better. So it's making array backed LRU cache abstract. I guess this one is abstract too. Oh, and then we do source path cache. It's got capacity. Yeah. Yeah, it sure looks like it's doing it. Wow. Okay. So now, so it seems like it's doing a great job. And compared to this workflow in with ChatGPT 4, well, what is the GPT 4 context window? It's like 32,000 tokens. Again, like the exchange rate isn't exact, but so it looks like ChatGPT 4 is about half as big as we need um, to just put our whole project in. Um, so the team that's porting from Python, these great students at SFU, they are working here in Selfie Python Whip, and they've been going kind of class by class, copying into ChatGPT 4, asking it to do the port, and then fixing stuff. But you have to, you're shuttling context into ChatGPT. Whereas with this, you just put all in there at the beginning. And it seems to understand the interactions between the different pieces very well. So we just did array backed LRU cache, which gets used by source path cache. So now, say provide a full implementation of source path cache. Curious if we ask it to do one of the Python things in the middle. So, like for the Python code that we have, and we're, I would say like a little bit more than halfway done. Comment tracker is a good one, I think, because so here we're in the original Kotlin code. So we have this code called slice, which is slices of a string. It helps with parsing and rewriting snapshot files. And then we have comment tracker, which you control Selfie by you control whether Selfie is reading or writing with comments. You put in a comment like //Selfie once. When you run that test, it'll write the snapshots in that file and remove that comment. It's always a error on CI if there's any writing comments. It means you don't have to mess around with command line flags. But to make that work, we have to do this parsing that uses slice. So we haven't asked it to do slice. So what if we say port provide a full C# implementation of comment tracker. Yeah, so it has writable comment, but it didn't. Keep going. Any specific guidance on yeah, see, so it is interesting. So so comment tracker uses array map type path. It doesn't have those. It doesn't have call stack. It's asking about snapshot and snapshot value. Yeah, it's correctly understood. These represent the core data structures for storing snapshot information. It understands snapshot, file layer, and FS. The file system abstraction is for Kotlin multi-platform, and it runs in the browser. You need to do weird file system stuff. Doesn't really matter for C#, but it still saw that it is there. Snapshot system and disk sort, it sees that's there. Round trip JSON. Didn't quite understand this. The round trip is not used for expect selfie. It's only used for cache selfie. Cache selfie. So when you're doing expect selfie on a value, you have the value when you pass it to expect selfie. You don't really care. When doing cache selfie and it's a function, you want that return value of that function. You might build things with the results of the cache selfie, even if you're running off of cached data, which is why there's this round trip. So it didn't pick up on that. But it seems, so it's funny, so it sees that comment tracker is using array map and typed path, and it doesn't have those. And it doesn't have slice, which it doesn't specifically call out. So let's say if we do provide an implementation of slice. Yeah, so compared to the ChatGPT workflow, it just understood the whole project structure right off the bat. So it's that way much easier. This, again, so look up slice here. So for example, trim. And look at its trim. Looks like it got it to me. First glance. Good thing is there's tests, so you would so slice tests. So convert slice test. Yeah. So looks like it likes XUnit. One of my questions was going to be like, which one of these is most popular or the best one, whatever. But because I'm not in this ecosystem, but if Gemini likes XUnit, XUnit works. So now we have slice. The other thing we're missing was type path. Now do type path. Keep going. So typed path, let's see what that is. Typed path is just a string, but it is a string that knows if it's a folder or not, because whether it ends in a trailing slash is significant. So it always knows if it's a folder. And you can get the parent folder with just string math, and then you can resolve files or folders, and it does, if you know you're resolving a file, it makes sure there's no trailing slash. If you know you're resolving a folder, make sure there is a trailing slash. This makes kind of string math on paths a little easier. Yeah, it's gotten mixed up here. That's not correct. Look at Kotlin code for type path. Carefully import it faithfully to C#. One of the interesting things is because we have a million lines of context and we're only using 50,000, for all of Selfie's source code, all its source and tests, we're only using 50,000. Yeah, so this looks exactly right. So now that we've done typed path and slice, now we should have everything we need for the comment tracker, which was the thing where earlier it said it would need more guidance. So now I think it has guidance because we've done these other ones. So now I'll do comment tracker. Okay, we have to be, so using the implementation of slice you provided earlier and the implementation of typed path you provided earlier. Look at the Kotlin implementation of comment tracker. Port the Kotlin to C# for comment tracker. It seems like it kind of got stuck here, and I'm not sure. Anyway, very impressive. You could make a lot of progress. Definitely could make a lot of progress quickly here, but it wouldn't get you all the way. But this makes me very, well, I'm curious about two things. One thing I'm curious about is Python convert slice to Python. Because that's the one where we have kind of the human to compare against. ChatGPT-4 assisted human, but the fact that this model can hold all of Selfie in there makes it much easier than shuttling the stuff over manually. So, wow, this is really similar. Slice. Oops. There you go. So here's an itself base string start index equal index. This is different optional int equals none versus -1. But same thing, if equals 1 equals len base string, len base same. Start index less than 0, raise value error versus assert. Base string started index ended. Yep. Len, get item. It's done the Pythonic was this snake case thing. Which I forget. Yeah, I guess object methods are still supposed to be snake case. Yes, is probably better than what we did here. More Pythonic. Wow. And self same as. It's good. This makes me really curious to try Claude. Because I'm gonna pause. Okay, I put in my credit card, signed up. I want to use the fancy model. Port this code from Kotlin to Python. So looks like I can't do a folder here, and I can upload at most 5. Upload a directory for Claude support zip. So one thing is I can definitely have a file per package. There's only 3 packages. So if I concatted all of them and removed package, that should work. Especially if I got rid of the multi-platform kind of ambiguity. The most interesting thing that happened here, I think, was the and it's an important thing here was what's Claude's context window. 200,000. So here we've got 1,000,000. Claude gives us 200,000, but we only need 50 to hold our whole code base, including tests, which we could do that separately. So concatenating these all into one file. So anybody concatenate Kotlin code to one file. Merge. Well, I'm getting sleepy, but let's try. The most interesting thing that happened here, one was just the quality that it did. It can remember the whole code base. We started off by uploading the whole code base. It knew the whole code base the whole time, and whenever I asked it to do anything specific, it did a very good job. One exception is comment tracker, where it just kind of got stuck. And what I've heard through the rumor mill is that Gemini 1.5, the context window is incredible, but it doesn't have, it's not as smart as GPT-4 or as Claude. So I guess I'm curious to start there. So if we focused on comment tracker, which would be comment tracker slice, and then typed path, this other one, which lives in snapshot system. What else does it use? Just make sure. Oh, it uses array map and atomic. Okay, so we'll put in array map, which is here. There's more of array map in here. This is complicated multiplier, so that's the 5 files that I think I'm allowed. And give it a command. Wow. Well, this is remarkable. It just does it. Let me try to make sure that I'm being fair. Because you can attach files here too. How many files can I attach in ChatGPT? 20. So have I just not been using this as well? Let's see. So for Claude, right, it's still going. Looks like it's doing it right. So wild. So comment, let's try to make this fair head to head. Right, selfie lib, comment tracker, slice, snapshot system, array map, and array map.jvm.kt. Okay. All of this code from Kotlin to C#. Still going. Looks like it kind of stopped in the middle. But also I think it did like most of it. And it also looks just like I think it did it right. I think it did it like very idiomatic. Next existing. Yeah, so it stopped. And it just kept going right from where it stopped. Wow. So if you're for ChatGPT, contents of the files. Start by importing each file to C#. Let's begin with comment tracker to KT. Talks about it. Yes, ChatGPT is still going too. So I think my big update here is I have not been attaching things to prompts because I thought of context as expensive from ChatGPT 3. And ChatGPT 4, even ChatGPT 4 has a 32,000 context window, which appears to be enough. So like these 5 files fit, and it seems like it's just ripping through it. And it's interesting how these new systems come out and kind of change the way you see the problem. So I've been managing how much I put into ChatGPT's context. The 1.5 model, the Gemini 1.5 with the million token context, was the thing they realized, well, my whole code base is only 50,000 tokens. And if ChatGPT's context is 30,000 tokens, it's not that far off. So you can get like most of it, just a lot of it in. And I see here, even ChatGPT 4 did like a big hunk here before it finally crapped out with this error. Compare that to Claude, which just went and went and went. And then when it finally did stop, I just said, keep going. And it picked up right there and kept going. I'm a little more suspicious, of this stuff, this part. This isn't very Oh, I don't know. Feels less idiomatic, but maybe it's right. Um, but definitely seems like Claude is more willing to do a whole bunch of work for you than ChatGPT is. And ChatGPT or Claude, I should be less stingy with context. I should attach files more. And Gemini 1.5, that 1.5 million context window, or what is 1 million, like that is really, if you put your whole project in there, it really is useful. But even Claude, like Claude's 200,000 token is like plenty for big stuff. I mean, selfie is not small, not huge, but it's not very small. And ChatGPT, I would have, the way that I've been working would be better if I had been attaching files, it looks like, versus pasting them in manually, and maybe attaching like more files around it. Interesting. Well, that's enough for now. I'm going to sleep on this thing about how best to use this. But definitely seems like Claude is worth its $20 a month for now. Seems worth it to figure out how to concatenate my code so it's easier to feed to Claude and other systems, but especially for Claude. Very cool.